Assignment 9.5, lesson 9.5 was on integrating inverse trig. Let's do this. Number 1, we're integrating from 0 to a quarter, 1 over the square root of 1 minus 4x squared dx. All right. So first I understand the form. 1 over the square root of 1 subtract 4x squared is the form of inverse sine. And so where does the hook come from? And it comes from this second part underneath the square root sign. So that's what we call the u, where the hook comes from. And that's the square root of 4x squared. So I need to take the square root of 4x squared. That's 2x. And then the derivative of 2x. 2 is the hook. That hook belongs in the numerator. So I'm going to write that in the numerator, but I then have to have 1/2 in front to undo that so it all stays equivalent. And that's it. Now I can unhook this. So the answer is 1/2. It's arc sine and u, which is 2x. And it's from 0 to a quarter. Plug it in. So I'm going to plug in 1/4 first. In fact, that 1/2 can just be in front, make it easier. So plug in 1/4. 2 times 1/4 is 1/2. Plug in 0, and that's 0. And then if you had to, you have to simplify this. So arc sine of 1/2, where is the y coordinate 1/2? And that angle is at 30 degrees or pi over 6. Where's the y coordinate 0? And the answer is 0. So if I put this together, the answer is pi over 12. All right, on to number 2. In number 2, let me just write it down. We're integrating from 0 to 5/3, and it's 2 over 9x squared plus 25. So when it's tangent, how are we going to understand how to break this down to do this? So a few different things here. Think of something u and think of something in terms of a. So the u is the square root of 9x squared. It's always the variable. So that's 3x. And the derivative of 3x is 3. That's going to be the hook on top. 25, that's what a equals. And it's the square root of that number. So a is the square root of 25, which is 5. Those are the numbers I'm going to use. So first of all, I need the correct hook. So I need the hook 3 in the numerator. So I'm going to write it with a 3. That's what I need. And that means what it was over what it became. It needs a 2/3 in front. So now I can unhook this. I know my answer is going to start with 2/3. And then I need to know kind of the formula for inverse tangent. So it's 1 over a. So it's 1 over 5. Arctan, and then inside is u over a, which is 3x over 5. And then we're integrating from 0 to 5/3. So 2/3, 1 over a, u over a, and we just need to practice it to know that formula to integrate inverse tangent. Now we're not done yet. We got to plug in. So this is 2 over 15. I'm just going to write that in front. And then it's arctan, and we're going to plug in 5/3. Now 3/5 and 5/3, they all cross out. That gives me 1 minus, if I plug in 0, that's arctan of 0. And then if I had to, arctan at what angle when you go y divided by x gives you positive 1. So that's at 45 degrees or pi over 4. At what angle, if you go y divided by x, do you get the answer 0? and that answer is 0. So 2 goes into 4 twice. So you could see the answer is pi over 30, or 2 pi over 60. Number 3. It's just practice. You'll get there. In number 3, the question, we're integrating from 0 to 1, x squared over x plus 1 dx. So the first thing I notice is that the numerator is more powerful than the denominator. This is not in the form of arctangent. So because the top is equivalent or more powerful, we have to do long division to make this work. So on the side, we're going to go x plus 1 into x squared and divide to be able to do this. So x squared divided by x is x, and then distribute. So that's x squared plus x. The remainder is really important here. So nothing, subtract x. The remainder is negative x. So our answer is x. That's actually the easy part. And then the remainder we write as negative x over x plus 1. Oh, we could have gone farther. Let me do this again. So I could go one more step. So what's negative x divided by x? It's negative 1. So negative 1 times x is negative x, and negative 1 times 1 is negative 1. Again, be careful of the remainder. So when you subtract a negative, the remainder is 1. So let's rewrite this here. I'm going to rewrite it right here beside it, not even let you look at what I did before. So the answer is x subtract 1. And then the remainder is positive 1 over x plus 1. So we have x subtract 1, the remainder over the divisor. And now I'm going to integrate that one at a time. So the integration of x, you add 1 to the exponent and divide. The integration of negative 1 is negative 1x. And this is a fraction. This is actually a logarithm. The derivative of x plus 1 is 1. So it's set up. And so that logarithm, what's in the denominator, goes inside the bars. And there you go. Oh, and I'm integrating from 0 to 1. So there's not even that. So I'm integrating from 0 to 1. So I still need to do a substitution at the end. So first I plug in 1. Subtract, then I plug in 0. That's 0, that's 0. 0 plus 1 is 1. Ln 1 is 0, so that whole thing is 0. And that's it. I mean, I could make it look a little nicer. That's negative a half plus ln 2. That's pretty there. And there's your answer. Number 4. See if we can recognize how to integrate this. You have to enjoy the puzzle of integration for you to be successful. Can you solve this puzzle? Identify what the form is and solve it. And if you enjoy the puzzle of it, you'll be successful too. All right. So this is in the form of arctangent. So if I look, u is the square root of that. So u is 2t plus 1. So the square root and the square cross out. U prime is 2. That's what the numerator should be. And then a is the square root of 2. And that's what it is. It's just the square root of 2. Now, I'm going to rewrite this. So the numerator should be 2. So I need a 4 in front because 4 times 2 is 8, so they're equivalent. So this is undone. And my solution, my answer is going to start with 4. Then I'm going to go 1 over a. So that's 1 over root 2. That's fine. And then arctan. And then it's u over a. So it's 2t plus 1 over a, which is root 2. And then plus c. There's no extra work at the end, which is nice. And that's it. Number 5. I know it looks worse than it is. I think once you understand the pattern and the formula, it isn't too bad. Integrate w squared over the square root of 4 subtract w to the 6th. Right? My eyesight's going. All right, so this is in the form of arcsine. So U is W6. It's the square root of that. So that's just divided by 2. Oops, that's there. W to the 3. U prime, the hook, then would be 3W squared. So I already know this is 3W squared, so I need a 1/3. And then A is the square root of 4. That's 2. And then the formula. So we start with 1/3 arcsine, and it's U over A. That's W cubed over 2. And then the candy. For arcsine, we don't have a 1 over A in front for the formula. All right, on to number 6. We're integrating from, no. It's an indefinite integral. It's x times the square root of 16 minus ln x squared. All right, so this is not in the form of arctangent or arcsine because of that x in front of the square root. It's not in that template. I'm going to write this calculus friendly to try to get a better sense of this. So if I write this calculus friendly, I see 1 over x. I see 16 subtract ln x squared to the exponent negative a half dx. Now, the derivative of 16 is 0. The derivative here maybe it is in the form of arcsine. So the problem here is if I take the derivative, this is the puzzle part. If I take the derivative here, I get 2 ln x and then 1 over x. It's not going to match what's in front. So this direction isn't going to help me. So I wrote it calculus friendly. It doesn't help. So instead I'm going to write it this way. I'm going to think of the 1 over x. I'm just going to put that in the numerator. It's the same thing. And then it's actually more in the form of what I'm looking for in terms of arcsine. So if I write it this way, I can see the arcsine. So let's break it down. U is the square root of ln x squared. So the square root and the square, that's just ln x. So the derivative of u is 1 over x. That's the hook that needs to be in the numerator. It is actually there. It's working. And then a is the square root of 16. So all of it is working. I don't need to add anything. I can unhook this. This is arcsine, so I can write down arcsine, and then inside is u over a, and then don't forget the constant or the candy. Number 7. So for these, I have to complete the square in order to do that. So I'm going to help you do that. It's not that bad. So in this situation, and if you see a trinomial in the denominator, it's likely arctangent. So I need to complete the square. To do that, think of this as ABC. Take the b value. That would be negative 10. Divide it by 2 and square it. So if I divide it by 2 and square it, that's going to be an important number. So that's negative 5 squared, which is 25. All right, I need that number 25. So I'm going to write this with a 25 on the bottom. That would be t squared minus 10t plus 25. So I need that number. This factors into a perfect square. But the number is 32. So 32 take away 25. I'm going to separate it. I need the number 7 to separate it. So 25 plus 7 is 32. but this in front is going to factor into a perfect square. And again, how did I get 25? Is I divide by 2 and square it to get that number. This now is going to be arctangent. So what two numbers multiply to negative 10 and add to 25 is negative 5 and negative 5. So that factors to negative 5 squared plus 7. Now I can break it down. So u is the square root of t minus 5 squared. So that's just t subtract 5. The derivative of that is 1. It's already there. And then a is the square root of 7. So my answer then, since it's arctangent, starts with 1 over a, arctangent, and then it's u over a. And then the constant. So that's what it means to complete the square, and then you can integrate. Let's try it again. Don't give up. Number 8. In number 8, we're integrating from negative 3 to negative 1. And again, I need to complete the square, and perhaps it's going to be arc sine. So how am I going to do that? So, in order to complete the square, I need to factor out a negative to begin with. But I only need to factor out a negative from negative x squared to negative 6x. I don't need it from the 7. Then you're going to take 6 and you're going to divide by 2 and square it. So 6 squared, or 6 divided by 2 is 3, and 3 squared is 9. Now, this is actually negative 9, and the number before was 7. So to keep it the same, I need 16. Because 16 subtract 9 is 7. These are exactly the same. I can now factor this. That's 3 and 3. And if you like, you can put the 16 first. So it's 16 subtract, so you can see it. This is definitely arc sine. U is x plus 3. U prime is 1. And a is 4, the square root of 16. So if I put it together, it is arc sine u over a, and we're integrating from negative 3 to negative 1. So we still have more steps here. So first, I'm going to plug in negative 1. So negative 1 plus 3 is 2 over 4, which is a half, minus arc sine. I'm going to plug in negative 3. Plus 3 is 0 divided by 4. Arc sine 1/2. At what angle is the y value 1/2? That's at 30 degrees, or pi over 6. And arc sine of 0 is 0. And there's your answer. Number 9. In number 9, you're integrating, and it's the square root of arctangent over 1 plus tangent squared d theta. And you're trying to think out, how on earth am I going to do that, right? So let's look at it. We're going to write this calculus friendly, just to see if we can make better sense of this. So the square root is arctangent to the exponent 1/2, And then what's left is really 1 over 1 plus theta squared. Now the derivative of arctangent is this, 1 over 1 plus theta squared. This is the correct derivative of arctangent. So it is the correct hook. I can unhook it, and then I just need to add 1 to the exponent. So 1 plus 2 is 3. And then divide or the reciprocal, and then the constant. Number 10. In number 10, we're integrating 5x over x squared plus 1 dx. All right, so for this one, it could be a logarithm, it could be inverse tangent, it could be write-it calculus friendly. We need to figure out the puzzle here. So if I take the derivative of what I see, I get 2x, and that works. That's because 5x and 2x, they're like terms. So the derivative of the denominator is 2x, what it was over what it became, so 5 over 2. They're the same. This can unhook, and this is a logarithm where x squared plus 1 is inside and it's over. We need to distinguish between arctangent, logarithm, calculus friendly. We have to be able to distinguish between them. Number 11, and it just comes with practice, right? There's an art form to it. There's experience to it that I have, that you're going to have. So 5x squared and x squared plus 1 dx. So the first thing I notice is the degrees match. So I'm actually going to divide to reduce it down. So 5x squared divided by x squared is 5. And then when I subtract, the remainder is negative 5. So my answer is 5. My remainder is negative 5 over x squared plus 1. Now, the integration of 5 is easy. How about 5 over x squared plus 1? Well, the derivative of this does not match the numerator, so it's not that. So it's not a logarithm. So is it arctangent? So if it was arctangent, u would be the square root of x squared, which is x. The derivative of u is 1. And then a would be the square root of 1, which is also 1. So this is arctangent. So we have the integration of 5. I'm going to separate it. I have the integration of x squared plus 1. The hook should be 1. So I need a 5 in front so it stays the same. And then we just integrate it. So the integration of 5 is 5x. This is going to be arctan. So it starts with 1 over a. Well, 1 divided by 1, so it doesn't affect it. Arctan, and then u over a. Well, x divided by 1 is just x, and then the constant. Number 12. In number 12, again, we just have to enjoy the puzzle of this. Cosine t, the square root of 25 subtract sine squared t. So when I see square root and subtracting in the denominator, I think arcsine. Let's see. So if that's true, u would be the square root of that, which is just sine. The derivative of sine is cosine. And then a is the square root of 25, which is 5. So it completely fits. So for this, we start with arcsine, and the hook is correct. So this is perfect. So we start with arcsine, and it's u over a. And that's it. Number 13. I wonder if you can challenge yourself and press pause and try it first. Let's see. E to the negative 2v. I mean, you should always do that, but if you need support, you need support. So this could be in the form of arctangent, but could also be in the form of logarithm and so on. So we just got to try to figure this out to begin with. So if I take the derivative of the bottom, the derivative of this would be e to the negative 4v times negative 4. It's not going to match. So it's not a logarithm, number 13. So let's see if it's arctangent. So if it's arctangent, then u would be the square root of e to the negative 4v, which just means you take the exponent and divide it by 2. So that's e to the negative 2v. U prime is the derivative. So that's e to the negative 2v times the derivative of negative 2v, which is negative 2. So if I look here, this should be a negative 2, which makes this negative a half. A is the square root of 3. And now we can write the answer. So the answer starts with 1 over a. Actually, it starts with negative a half, and then 1 over a. And then it's arctan. And then inside is u over a. So it's e to the negative 2v over a, which is root 3. And then the constant. I know it looks tougher than it is. I honestly think that if you follow the pattern and the structure, it's not too bad. But I know it takes practice. Number 14. This is going to be a good one. So be prepared for like a big piece of paper. 14. But I'm not scared by it. I'm just telling you. So right away I see cube root. So there's no way that this is an inverse nothing. So cube root does not follow what it needs to be. So I'm going to write this calculus friendly and kind of go from there. Because the derivative of the denominator doesn't help me. It's not a logarithm. It's not arc sine. It's not even subtracting. It's cube root. It doesn't match. So I'm going to write this calculus friendly. And then what I notice when I write it calculus friendly, so that's to the negative 1/3, the derivative of this does not match this. So I can't create the hook and unhook it. There's no anti-chain rule here. Instead, I have to do a U-substitution. So I'm going to let u equal 3x plus 1. I'm going to solve for x. So if you solve for x, x is that. U subtract 1 all divided by 3. And then the derivative of x is 1/3. So that's like 1/3 u. And that's du. All right. So I'm going to use this and this where I need to. And I'm going to do a substitution. So where there's an x, x equals u minus 1 over 3. 3x plus 1, that's just u. And that's to the exponent negative 1/3. And then dx is 1/3 du. So I'm going to put the 1/3 in front. In fact, I'm going to take the 2 and make it 2/3 in front just to make it easier. Oh, and the 3. Why not? So it's actually 2/3. Let's put it all in front. That's 2 over 9. Then I don't got to worry about these fractions. So 1 times 2, 3 times 3. Let's get all of those in front. So it's 2 over 9. So we have u subtract 1. U to the negative 1/3 du. And now let's do some work. So now I need to do algebra. So we have 2 over 9. When I multiply, I'm going to add to the exponent. So 1 and negative 1/3, if I add them together, that's positive 2/3. Negative 1 in this is just negative u and negative 1/3. And now I just have to add 1 to the exponent. Add 1 to the exponent and divide. So add 1. 2 plus 3 is 5. and then the reciprocal. Negative 1 plus 3 is 2, and the reciprocal, oops, that's 3 over 2. And then the constant. And the last thing I need to do just making sure. Last thing I need to do is plug x back in. So I have 2/9, I have 3/5. U is 3x plus 1 from here, right? U is 3x plus 1. So take out the u, put in 3x plus 1. And there you go. And you have your answer. I know. So that was a good one, right? That's okay. Number 15. It's going to get better now. So in number 15, you have y equals negative 2 cosine 1/2 x minus a pi. X minus a pi. All right. Then sketch the graph of the function. Okay. So the amplitude here is 2. The period would be 2 pi, but we're going to divide it by a half or times 2. So it actually doubles the inverse of what you see. And the phase shift's at positive pi. We're going to draw a graph. We're going to count to 4. 1, 2, 3, 4. That's one period, which is 4 pi. That's 2 pi. Okay? So that's how long it is. 1, 2, 3, 4. It goes up to 2 and it goes down to negative 2. Cosine starts at the top, but negative means it's been reflected, so it starts at the bottom. And at the phase shift, pi is where it starts at the bottom. So find pi and at the bottom of the wave, and then just complete the pattern, and you're done. Number 16. In number 16, another graph. I like sketching trig graphs. 2 cosecant. I know, weird that way. Pi x. Do you remember how to graph that? No amplitude. The period would normally be 2 pi, but I'm going to divide it by pi. So now the period is 2. So what's the magic number again? We're going to count to 4. 1, 2, 3, 4, and that's one period, which is 2. So this is 1. There's no phase shift or anything. Secant starts with an asymptote. The 2 is where the vertex is. And negative 2. And because it's positive, it starts at positive 2. And then it goes to negative 2. And there's the picture of 2 cosecant pi x. All right, number 17. Turn the page. Yay, we get to turn the page. Making sure my pages are together. I find that I should have spiraled them together. This glue, hot glue on the binding didn't work at all. All right, number 17. These are limit questions. So I'm thinking Lopatel's rule or substitution and so on. So to understand this, take the limit of only the numerator. So the limit as x approaches 0 for 10x. So substitute 0 in for x. Tangent 0 is equal to 0. Do the same thing to the numerator. And you can already tell, x, secant x. So the same thing to the denominator. Plug in 0 for x. Secant 0, it doesn't really matter because 0 times anything is 0, but it's 1. This is indeterminate. So we're going to use Lopatel's rule because it's indeterminate. So the derivative of tangent is secant squared. This is the product rule. The first times the derivative of the second. So the derivative of secant is secant tangent plus the second times the derivative of the first, and the derivative of x is 1, so that's good. Now reevaluate. So plug in 0 for x. So the value of secant at 0, that's the reciprocal of cosine, or the reciprocal of the x value at 0, so it's 1 squared, or 1. In the denominator, the value of tangent at 0 is 0, so it's 0 times, so this is 0. The value of secant at 0 is 1, so put it all together, and the answer is 1. Number 18. The limit as t approaches pi over 4 of cosine t subtract sine t of 2 subtract 2 tangent t. All right, we're going to separate it. I'm not going to assume that it's Lopatel's rule until I see it. So the numerator and the denominator. So the limit as t is approaching pi over 4 for this. 45-degree reference angle, so they're the same number. So you subtract, the answer is 0. The denominator, the value at pi over 4 for tangent, y divided by x, is 1. So 2 times 1 is 2, and 2 take away 2. It is indeterminate. So we're going to use Lopatel's rule. So for Lopatel's rule, the derivative of cosine is negative sine. The derivative of sine is positive cosine, but it's negative because it's negative already. The derivative of 2 is 0. The derivative of negative 2 tangent would be negative 2 secant squared. Now we're going to plug in again. So plug in pi over 4. That is root 2 over 2. Plug in pi over 4. That's also root 2 over 2. Plug in for secant. So it's the reciprocal. So it's actually root 2 squared. That's the value of secant at pi over 4 is root 2, and then you're going to square it. So let's see if we can have an understanding of this. So this is negative 2 root 2 over 2. This is root 2 squared, which is 2 times negative 2, which is negative 4. The 2's divide out, and I get negative root 2 over 4 as the value of that limit. That's a good one, right? I got a negative answer. Should I got a negative answer? Yeah, because a negative divided by a negative would give you a negative answer. So it's positive root 2 over 4. Perfect. Number 19. Another limit question. Don't assume it's Lopatel's. We'll see. So theta as it approaches pi over 2. So I can already tell you it's not. Because when I do the limit with pi over 2, the cosine of pi over 2 is 0. But here, 2 times, well, maybe it is. I shouldn't speak so soon. Let's just try it. So if I plug in pi over 2, the 2's divide out. So it's just the value of sine at pi, which is the y-coordinate, which is 0. And then as it approaches pi over 2 of the denominator, that's at the top of the unit circle. The x value there is also 0. So it's indeterminate. So it is Lopatel's rule. Take the derivative of sine 2 theta. So that's going to be cosine 2 theta. And then the hook is 2. The derivative of cosine is negative sine. And then we do the work again to reevaluate. So plug in pi over 2. They divide out. So the value of cosine at pi is negative 1. The value of sine at pi over 2, again, is at the top of the unit circle. It's positive 1, so negative sine would be negative times positive 1. The negatives divide out, and then the value of the limit is just 2. Those are good questions. Number 20. Let's try again. Practice. Find the limit as x approaches 1 of arctan minus pi over 4 over x minus 1. So again, I'm going to separate the numerator and denominator. So we don't want to write down 0 divided by 0. If I plug in 1 for x, the angle where tangent's 1 is pi over 4. So pi over 4, take away pi over 4, it's 0. The denominator, what's the limit as x approaches 1 of x subtract 1? Plug in 1 for x, and the answer is 0. It's indeterminate, so I'm going to use Lopatel's rule. So the derivative of arctangent is a fraction. It's 1 over 1 plus x squared, right? Make sure I remember my derivative rules. And the derivative of x subtract 1 is 1. So now I'm going to plug 1 in again, and it's 1 squared. So it's 1 over 1 plus 1. So that answer is 1/2 divided by 1, or 1/2. All right, number 21. In number 21, y equals 2 arctangent e to the 2x. And it says just take the derivative of that. So y would equal, so it's 2. Now the derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. So it's really going to be a 4 in the numerator once you simplify it. And then it is 1 plus, and you square this. So when you square e to the 2x, you're just multiplying the exponent by 2. So that's e to the 4x, and it's done. Number 22. That's how we're going to remember our rules, right? It's just practicing them and practicing them. F at x equals ln arc sine. What's the derivative of this? So for ln, what you see is in the denominator. The derivative of that what you see is the numerator, the hook. So the derivative of arc sine is 1 over the square root of 1 minus x squared. I don't need to make it look nicer than that. And it's done. Number 23. So g at t equals sine arctangent t. What's the derivative of that? So this is the chain rule. So the derivative of the outside, so the derivative of sine is cosine times the derivative of the inside, which is 1 over 1 plus t squared. Whoop, there. The derivative of arctan. '24. Just always checking to make sure I didn't make a mistake. We have 4 cosine x sine y minus root 6 is equal to 0. And then it says take the derivative at that point. So can you take the derivative implicitly? So let's see if we can do that. So to take the derivative, it's going to require the product rule. So the first times the derivative of the second. So the derivative of sine is cosine, but it needs a y prime, plus the second, sine y, times the derivative of the first. So that's going to be negative 4 sine x. The derivative of negative root 6 is 0. And the derivative of 0 is 0. So already there is the derivative there. So again, the first times the derivative of the second plus the second times the derivative of the first. All right. So then I'm going to write 4 cosine x cosine y, y prime, equals, and I'm going to, this is negative, so I'm going to add it to the other side. So that's 4 sine y sine x. I'm going to divide it to get y prime by itself. So 4 sine y sine x, 4 cosine x cosine y. Notice the 4's divide out, and then I want to take the derivative at a point, pi over 6 and pi over 4. All right, here we go. So the y value is pi over 4. The x value is pi over 6. Pi over 6. Pi over 4. And then, do I know my unit circle? So the value of sine at pi over 4 is root 2 over 2. The value of sine at pi over 6 is root 3 over 2. The value of cosine at pi over 6 is a half. The value of cosine at pi over 4 is root 2 over 2. So the root 2 over 2 divide out, the 2's divide out, and you're left with root 3 over 1, or just root 3. Isn't that nifty? I did a mistake. So the value of sine at pi over 6 is 1/2. I knew I made a mistake. And the value of cosine at pi over 6 is root 3 over 2. So, again, the root 2 over 2's do divide out, and the 2's divide out, but it's 1 over root 3 is the answer. And you can leave it that way. That is nifty. All right, 25. We're almost there. For number 25, integrate secant squared 2x and the square root of tangent 2x. So this feels like a make it calculus friendly kind of question. So I have secant squared 2x and then tangent 2x all to the exponent negative a half. Yeah. So the square root in the denominator is written as the 1/2 negative a half. The derivative of tangent is secant squared 2x, but it needs a 2 for the hook, so it needs a 1/2. So my answer is going to start with 1/2, and then I write tangent 2x, and then I'm going to add 1 to the exponent. So negative 1 plus 2 is positive a half, and then the reciprocal plus the constant. So the 1/2 times t, they really cross out. So it's just tangent 2x to the 1/2 plus c. Checking. Yeah. All right. Number 26. E to the t cosine e to the t over sine e to the t. All right. So which one does this feel like? Calculus friendly or a logarithm or something else? And it feels like a logarithm. So how I feel is this. What's the derivative of the denominator? So the derivative of sine is cosine e to the t, and the derivative of e to the t is e to the t. So that's the hook. And when I look at that, they match exactly. That's beautiful. So this can unhook, and my answer is a logarithm, sine e to the t plus c. Perfect. 27. For number 27, we're going to integrate cotangent squared 3x dx. And it says you need to make a trig substitution. So let's just do this quick. Sine squared plus cosine squared is equal to 1. I want cotangent. Cotangent is cosine over sine. So I'm going to divide everything by sine. By dividing everything by sine, sine squared divided by sine squared, that's 1. Cosine over sine is cotangent. And 1 over sine is cosecant. So cotangent is equal to 1 subtract cosecant squared. So I'm going to do a substitution with cotangent squared with this, so I can do it. Oh, wait a second. It's cosecant squared minus 1. So you subtract 1. So cosecant squared minus 1. All right, let's go back here. So I'm going to write down cosecant squared minus 1. Those are the same. Now, I have a rule for cosecant. So first of all, the hook for 3x is 3. So I need a 1/3. So the 3 goes, so it starts with 1/3. The rule for cosecant squared is negative cotangent. And then 1 is just x, and then the constant. So it's negative 1/3 cotangent 3x minus x plus c. All right, number 28. All right, how do I find the average value of a function? Man, that was a long time ago, so let me help you. The average value is found by integrating. So I'm going to integrate that function. And we use the bounds, 0 to 1/2. And then we divide by the difference of those bounds. I know, that was a long time ago. This is arctangent. So u is 2x, u prime is 2, and a is the square root of 1 or 1. Oop. So if I write this properly, it would be 4 and 2, and then unhook the 2. So our answer is going to start with 4, and then it's 1 over a, which is just 1 over 1, which is 1. And then arctan, and it would be u over a, and it's just 2x over 1 or 2x. And that's all divided by 1/2. And then my lower limit and upper limit. 4 divided by 1/2 is 8. So we have 8. We can keep that in front. And then it's arctan. I plug in 1/2. So 2 times 1/2 is 1 minus arctan of 0. The angle where tangent is 1 is pi over 4, and this angle is 0. So if I put that together, the average value is 2 pi. I did something wrong. What did I do wrong? At the beginning, I did something wrong. Did I write it down wrong? I did write it down wrong. Ha! So, the answer should have been 6. This was 6. That doesn't help. If right at the beginning you write it down wrong. So this is 2. This needs to be a 3. So 3 times 2 makes 6. So as I work along here, that should have been a 3, and then that's a 6. So if I do that, that's 3 pi over 2. If I reduce it down. Doesn't help, right? If you write down the question wrong right at the beginning. All right, 29. Don't give up yet. We got this. Press pause if you need to. I'm going to keep pushing. Find the area of the region bounded by y equals 3 over the square root of 9 subtract x squared and that. Okay, so if I graph 3 over the square root of 9 minus x squared from 0 to 1.5, so I know it's integration. So to find the area there, if I would graph this from 0 to 1.5, all these values would be above the x-axis. I'm not going to find the exact value of them. Like if I start here, plug in 0, the square root of 9 is 3. So like it starts at 1, and then it increases from there, right? If I was going to sketch it, this is what it would look like. But basically it's top, subtract bottom. So that's what that is. The bottom is 0. So subtract 0 doesn't do anything. So your bounds are 0 to 1.5, and you integrate to find the area under the curve. So this is arc sine. U is x. U prime is 1. A is the square root of 9, which is 3. So it's arc sine U over A, and we're integrating from 0 to 1.5. So arc sine 1.5 over 3 minus arc sine of 0. So the arc sine of 0 is 0. So 1.5 is a fancy way of saying 3 over 2. So 3 over 2 divided by a third, 3 or times a third, that just is 1/2. So arc sine 1/2 at what angle is the y value? And the answer is pi over 6. Oh, and there, I didn't even think of the hook, right? So the u prime was 1, so this should have been 1, which means that needs to be 3, so that it fits. So my answer is actually 3 arc sine that. 3, and so this would be 3. So pi over 6 times 3, and you get pi over 2. All right, number 30. That's why I got a answer key to make sure that I'm on the right track. We're almost there. These are the easy ones at the end, hopefully. Yeah, we can do these. Arc tangent, -1 over root 3. If tangent's negative, the angle is negative, and it's y over x. So the y and the x. And that what reference angle is this? So it's 30 degrees. So it's negative pi over 6. For 31, you're given that arc sine is 2/3. It's positive. So that means it's in quadrant number 1. So opposite over hypotenuse. I'm finding my wire here. And then find this. So 9 take away 4. That's the square root of 5 using the Pythagorean theorem. So, and I'm supposed to find tangent. So that means tangent y would equal opposite over adjacent. So it's 2 over root 5. Make sure. There it is. Hey, we're there. Number 32. Here we go. You ready? Not even. Right there at an hour. Incredible. Arc sine. That's my goal, is to make sure this only takes an hour. X squared subtract 1 equals pi over 6. Can you solve this equation? I got 40 seconds. The inverse of arc sine is sine. So that would be sine pi over 6. The y value at pi over 6 is 1/2. Add 1 to the other side. That's 3 over 2. Take the square root, and the answer is positive and negative root 3 over 2, and you don't have to make it look any prettier than that. Did I get it right? Say I got it right. Yep, it's it. Mr. G Math, over and out. I'm proud of you that you got to the end of this assignment. We're right there at 1 hour. So I'm pretty proud of that. That's cool. Till next time.